Go ahead and start the video. 3,
I already started the video.
2, 1, go.
Ooh, Speed Demon.
So basically what this position graph just shows is the distance and the change in distance with the time. So like this shows that it went 5 meters in 3.67 seconds. And this line just represents the velocity, and as you can see, it's faster at the beginning and it slows down towards the end, so the velocity is changing. So going off of what I said last time about velocity changing, this graph shows the velocity is changing, and it starts off with the highest velocity and it decreases as it goes. So like when it's 3.67 seconds, it has a velocity of 1.36 meters per second. And then this line just represents the acceleration, and it shows, since it's straight, it just shows that it's constant. So lastly is just the acceleration graph, and basically it just shows that it's constant and it stays at 0.37 meters per second squared the whole time because there's no rate of change in the velocity.
Alright, this is our force, and this is how we found force in ours. First we made a free body diagram, FW, which is the weight in kilograms times 10 to get newtons, 1.6 newtons, and then FW Fn equals FW, so 1.6 equals 1.6, and then friction force is the total force, because that's the only thing that's acting upon our car, and so then we used force equals mass times acceleration. We already know the mass, so we had to find the acceleration, and acceleration is initial velocity minus final velocity divided by change in time. So we found the velocity here, and then the acceleration here, plugged it in the equation, and our final answer was friction force equals 0.592 newtons.
So the formula for momentum is just P equals mv, and so P equals mass times velocity, and our mass is 0.16 kilograms, and our velocity is 1.36 meters per second. So we multiply that together to get P, and it is 0.2176 watts. So impulse is just the force acting during a period of time, and impulse is also just the change in momentum. So that's represented by the equation J equals F delta T, and so we plugged in 0.0592 for our force and 14 for delta T, and then we multiply them together to get J equals 0.8288 kilograms per meters per second.
Alright, the next thing we solved for was energy. There was no potential energy in our car, so KE equals work, and the formula for KE is half mv squared equals W, and so plugged everything in, and work equals 0.148 joules.
So at first my car starts off at rest and it hasn't moved at all, so it has no kinetic energy at all. But then once it starts to move, it has kinetic energy, and as it moves, work is put out of it as it keeps going, and friction starts to get affected by the car. And so as the friction goes against the floor, the car starts to lose energy and eventually ends up at zero. And this is talked about in the laws of conservation of energy, and it's just how friction affected the kinetic energy of the car.
Yay. I can't do it anymore. Alright, so the next thing we solved for was oh my god. No potential energy in our car. Alright, I can't rub my eyes, that's just not classy. Squared equals W, and then oh my god. Stop. Oh my god. Sweating balls.